This is Mufakirul Islam. Welcome to my presentation on fused deposition modeling of thermoplastic materials. Fused deposition modeling is one of the most prominent additive manufacturing techniques, and it is the most extensively used technology for fabricating thermoplastic parts. Those are generally used as rapid prototypes for functional testing, with convenience of low cost, minimal wastage and ease of material change. Fused deposition modeling was first introduced in 1990s by Stratasys company in US. Like other additive manufacturing technologies, fused deposition modeling starts with a CAD model. The CAD model is then transferred into STL file. The STL file converts it to a 3D model, and 3D model is then converted into a number of 2D slices, and according to this 2D slices geometry, the extruder path is generated. Part programming of this path planning is given to the computer numerically controlled FDM machine, and as shown in the figure, the filament of the spool is fed into the liquefier top using feeding pressure, and which is generated from a drive gear and a groove bearing. Plastic parts can be made layer by layer through depositing the filament material, which is heated up to a glass transition state and extruded through the extrusion nozzle at a constant temperature. Liquefier's head moves on the XY plane as a tool reaction created by the software and deposits the first desired layer at the time onto the print bed to form a base for the part. When the primary part layer is completed, the build platform steps downward for one layer thickness for the following layer of the filament material fabrication. After the FDM process is finished, the support material can be easily removed either mechanically or using a chemical solvent. Thermoplastic materials can be characterized as the polymers, which get softened during heating and can be remolded in different shapes. Based on the degree of the intermolecular interactions between the polymer chains, the polymer gets an amorphous or a crystalline form. Both forms can exist with thermoplastic polymers. The different type of thermoplastic polymers used in FDM process, and some of them are acrylonitrile butadiene styrene ABS, carbon fiber reinforced plastic CFRP, polylactic acid PLA, high impact polystyrene HIPS, and some other are PEEK, PC, PA and PS. There are different process parameters like rod angle, rod orientation, rod width and thickness, and wear gap, which play an important role in the global mechanical performance of the FDM finished parts. As shown in the figure, the rod thickness is the thickness of the deposited layer, and the rod angle is the direction of the filament with the x-axis of the build platform, and air gap is the gap between the rods of the same layer. The mechanical behavior of FDM parts, starting with the negative air gap, which is like the overlapping of the adjacent rods, and which was shown to increase the tensile strength by improving the part density, as shown in the figure, where increasing the deposition speed and rod thickness maximizes the final part's tensile strength, and the bonding strength is comparatively lower for the rod thickness when combined with the slower deposition speed than with the higher deposition speeds. The orientation, like 0 degree by 90 degree, exhibited a large increase in tensile strength compared to negative 45 degree by positive 45 degree. The addition of 90 degree layers parallel to the applied load lowered the flexure resistance within the cross ply configuration as compared to the angle ply configuration. The angle ply has contribution of overlapping layers with positive 45 degree and negative 45 degree, which increase the part's capability of carrying bending loads. Compared to the pure plastic specimen, adding carbon fiber into the plastic material could increase the tensile strength and young modulus, but may decrease the toughness, yield strength, and ductility. FDM PEEK parts demonstrate better mechanical performance than ABS because PEEK behaves as a block and improves the load transfer. You can see the fracture surface of ABS and PEEK FDM parts. The application of FDM thermoplastic parts. While FDM system has been broadly used for prototyping and induced parts in design and functional authentication by various industries, researchers have exploited the uncommon building styles and features of FDM technologies to develop scaffolds and new biomedical in tissue engineering, concept parts, production parts, lightweight custom jigs and fixtures, material flow monitoring, medical models in biomedical engineering, and to apply to various rapid thermoform tooling and casting operations. This is all from me right now, and thank you so much.